Can everybody listen to me?
No. Yeah, we can hear you.
Yep, great. Okay. I will try to leave things. Jack, feel free to interrupt me if I am not catching something. Someone is asking from the chat or there. Like being remote it will probably be more challenging for me. I will try to keep an eye there. So, well, thanks everybody for joining, for listening to on this talk. Stop video, yeah. Okay. So in this talk, I wanted to go through some patterns, some construct that we have in the language, in the standard library to deal with information going out or going in the system, which is basically a lot of applications need to do that somehow. But I want to go into the details of how those things work and how to keep an eye for either performance tips or for happier execution of the program at all. Maybe when we jump on some code, we might copy blindly what is given to us, and we just are losing the focus on how the execution is being done, and that could affect the application. But towards the end or in the middle of the talk, I might go into some others ideas, things that are not fully implemented, but are things that I care or try to care when I'm doing some applications, not always succeeding, but it's some of the ideas that I have in mind present when I am coding an application, and you will see. I hope you will find interesting, and at least there are some of my thoughts around there. But we will focusing on stream of information. So yes, I already said mostly about this. There are some open questions or ideas for future work, maybe as for the language itself or for external libraries, but we will be focusing on some specific scenario with specific source and see how that will execute. I don't expect to do demos, but there are a bit of code snippets there for us to discuss. All clear? Is it listening okay there? Yep.
Yep.
Cool. So we will start simple, but we will evolve to a more complicated scenario, hopefully really soon. One of the examples is just put to a terminal. Everybody knows this. Everybody starts with a simple program. And we can have two basic programs that kind of do the same effect on the console. The first one will use string interpolation, where we use the syntax for interpolating objects there. And the other, maybe depending where you're coming from, you might just use concatenation of strings. Although the effect for the user is the same, but we can argue that one of these two syntax is nicer. It's definitely subjective, but I will say that the first one should be probably more nicer. It's more fun to type. But the other question is, what is the machine doing while executing this? And there is a difference. We will dive into to find which are the differences, although I expect many of you already know which is the difference. One of these two use better the resources. Everybody knows which one?
I think interpolation.
Interpolation, yeah. Good, yeah, right answer. Awesome. So the one that is nicer is also the one that use better the resources. That's that's ideal. That's the best scenario that we can have. We are not sacrificing what code we want to type in order to get the best execution. Okay, so it's a simple scenario, but that's a nice thing to happen. So another more maybe far-fetched thing to mention is that when we are output to a terminal, I see that the information we want to output is all available for the program at the same time. It's all in memory there usually, because we are generating small strings, and we want to show those pieces of information in a specific order. We want first to say hello, which is a prefix, and then whatever value is in the object. This is particular for this scenario. This will change eventually. So if we go into the details and we try to say, hey, how the string interpolation is being executed and why is it performing better? If we dig into the compiler's code, there is a class in the compiler that's called literal expander. And this is the documentation there. I removed the code, but it's basically something in the compiler that performs all the syntax sugar things. So instead of writing full bar bus with interpolation, it's being replaced, as in the source code will say, we'll create a string builder, we'll append the value of bar and the literal bus, and then get the final string from the string builder. It's literally rewriting, a code rewriting. That's all that part of the magic. I hope I'm not spoiling too much of the Ari talk for the next month. But this is one part of the of the magic. It's like a syntax sugar, a replacement. There is no further analysis in this phase. It's just a code rewrite. Although it's slightly, there is some pending PR to change this to another expansion of the code, but it's essentially the same. There will be another method that will take the pieces of the interpolation and execute it somehow, because there is, this is the semantic of the interpolation. There is no other code than normal standard library code for doing the interpolation. So the magic ends there, at least in this, here in this string interpolation. So this class is the representation of this, and you will extract the pieces and expand the code. Ari will talk about that probably in the future. So what we have is that thanks to that expansion of the interpolation, the first code is equivalent exactly to the second one, although nobody will write this if you can write the first one, definitely. Right? Who will do that? But and then maybe changing the code for us to following up, we can rewrite that code to a sequential of appends of the string builder, and then finally getting the string of the string builder, because after every append, the same string builder is returned. So this the second and the third snippet are equivalent. Okay. Definitely nobody will write this the third one. We don't want to write that code. Let's get into this when we are appending the object to the string builder itself. What we'll have there is that for the string builder that is an IO, whenever you want to append whatever object, the method 2s will be called for that object, passing the IO. So in this case, we are doing string builder append object is the same as object.2s passing the string builder. So these two are equivalent. what this method allows is for the object to print itself directly to the I/O. And that's the important thing. One object can print itself directly to the output I/O, whatever we want, without probably doing intermediate strings. Like that's why as different from Ruby, when you want to define how an object is printed, you don't need to override the method 2s that returns a string, but you need to override the 2s that accept an I/O as input. That will allow you to print directly to that output, maybe without creating an intermediate string. So that's crucial. And for example, the implementation, the default implementation for the toString of an object is actually creating a string builder I/O and extracting that string. So that's why you should never override that method directly. You should use the one that accepts the I/O and you output there. So finally, if we count whatever how things work, in the first example, we are creating one string at runtime. There is an extra s there, right? One string at runtime, and the other one will be creating, well, here there will be one string being created, this will be the second one, and this will be the third one. So we are creating 3 objects to generate the same messages. Okay, so that's the difference. One is creating 1, the other is 3. Maybe it's not a big deal for a short living application, but we are allocating more than what we need. So my question is, can we do better? Maybe we don't need to do better, but it's a nice question. Like, can we do better than this to express this string interpolation and printing to the terminal? I hope everybody is asking for that. So the question is, why we even need a string to be created? Because there is a way. Like if we, instead of writing puts with hello object with interpolation, if we have written this, which is uglier to write, it's more like C++, like it seems like that. But in the second snippet, there will be no additional string allocation because even the object will emit directly to the standard output. So why can't we express in the nice way this execution that it could be slightly better because there will be almost no memory footprint involved? Okay, so that's maybe the question. Like, can we get to that point? It's not that I envision that that we need to implement this right now, but it's a question to motivate other scenarios later. But this is the simplest scenario. So let's imagine that we want to implement that. How can we allow this expression to behave as this program? There are a couple of ideas. Again, we are just doing an imaginary situation. It's not that this is going to change, but for example, something that you will need with the things that are right now is first, the puts expression should not be a method call because that will require to resolve the argument expression and then passing that value to put. So there you will already resolve the string interpolation despite for what is being used. So we will need to convert puts expression to a macro, for example, so we can pass the expression itself as a program without being executed to manipulate that information somehow. And from there, we could have like 2 alternatives. If the puts expression is doing std out and append and the string interpolation, we will need to give the semantics to the compiler to say, hey, you are appending to an IO, and on the right-hand side, you have a string interpolation. I will compile this in a different way without actually resolving the string interpolation to a string. That is one of the ideas, but there are some challenges there because that means trying to understand why the sign for append is used between an IO and a string interpolation. And for example, the same operation is being used for an array. So giving additional semantics or letting the compilers understand the semantic of the operation is a slippery slope. Maybe you don't want that. The other alternative is to have a special syntax for appending a string interpolation that will allow to deconstruct. If we want that, maybe the macro code of puts could allow that special syntax to get inserted, so the programmer will still write puts and string interpolation, and things will be able to execute better. Those are, with the current state, more or less the two paths that could happen. Is either one or the other one. There are some discussion, for example, of how this could have been done or can be done in the future. And there is in the issue 1267, it's exactly this same conclusion, more or less. So if you're interested in that, you can read that. It's not that it's something that I want to push, but it's a nice exercise. Like, what are the pieces of the compiler of the semantic that I need to change for that to behave different? Okay, is it clear? Any question up till now?
I think I got it so far.
Great.
We do have a question. Just like, what's the point of doing all of this? Like, doing it better?
What's the point of, what was it?
I mean, he's looking for better ideas of appending to IO, I guess.
Yeah.
Like, what problem does it solve?
The problem that we are aiming is for less memory for footprint. We have two expressions, one that create one intermediate string, the other create three, and we are saying, can we do something that does 0 new string interpolations? Because in this program we are able to do, we are outputting this constant, so there is no new string other that is already in the compiler itself, and emitting this object will depends on the code of the 2s of the object, but it could directly send the data, the pieces, to the std out without even creating new strings. So we will have even less memory footprint if we do these kind of things. I'm not saying it's worth it, but it's interesting to understand which are the pieces involved to change that behavior.
Awesome.
We have changing the semantics, the runtime of the programs, but preserving the fun syntax.
When you have a break for questions, I have a few, so I don't interrupt you though. Just for people who might be watching this that don't know IO, can you give like a very brief explanation of what an IO is?
Okay, the IO is it's something that represents inputs and outputs, like sources of inputs and source of or destination for outputs. A file, a standard output, standard input are all represented as IOs in Crystal. Buffers for memory buffers for building strings, for example, like string builder is also an IO. A socket for getting a connection to an external server is also an IO. Some ones might be bidirectional, someone might be only for input or only for output. An IO is the base class in the standard library that allows this integration. So when you are doing the append operator, you are sending data from the IO. Yeah.
Just to be clear, like this work would actually basically affect any time that you interact with the program outside the one you're writing. So making this more performant is to be like more performant for anything that your program kind of interacts with.
Yes.
Okay.
Yes. unless you are only like, if you only load information one and the most consuming task in your application is crunching numbers, like Bitcoins, maybe this is not that different. This will not have that impact. But usually, like, well, we will see later. We have an example of HTTP server trying to perform some output, and this could impact there a lot.
Okay.
So, but the thing is, so until now we have, okay, I can do puts with the string interpolation. I could change the execution for that. But the thing is that we don't only use string interpolations for printing to the console. For example, we have seen, I have code, some code like this, that when you're creating intermediate strings, like building the full name of a user based on the pieces, and then you want this, you put the full name. So this, again, there is a way to write a program that does exactly the same as this line without creating intermediate strings. So why does our program can't do, why our program can't do that? Why we are sacrificing runtime? Because the meaning of the program is pretty clear. So the question is, can the compiler even detect this same behavior and perform better, like avoiding intermediate string? This is even harder than the previous one. Like if you will have a method full name, like the code before, this full name returns a string. If we have a full name that accepts an IO, I could print the first name and the last name in that IO instead of returning the string. But it started getting messier. Like my code, I wanted to write about strings, and then I'm faced with writing a lot of things with IO, which is less fun. It's more cryptic. It's not necessarily better for the programmer, right? So and when we reach that barrier, we kind of like, well, let the execution suffer, because programmers wants to write fun code. At least that's my experience. Like, yeah, but this is the code is simpler this way, and then you start sacrificing the runtime. Again, this is a far-fetched scenario, really small, but we are trying to make it easier for later to understand other scenarios. So things that can happen is, like, if I have an IO and I emit the result of the method call, that will be creating the intermediate string. A different will be to have a similar method that accepts an IO, and then the result is there. That is what I'm doing. I don't want to decide how to code these kind of things. It's the same. I am computing the full name. I don't want to deal with IOs and strings. It's too cryptic, even for explaining it. Sorry. So let's get back to the focus to simpler scenarios. That we want fun expressions and neat execution. That is all what I want. And to sum up to here, what I have is that the methods itself allow us to express some computation, some way to get the result that we want from the input, like concatenating first name and last name and getting the full name. But then for having better performance, maybe we will need that result to not be in memory, but to be in the IO directly. But then we need to have that in mind when expressing the code, right? So that is what's happened here. Like, we can create a lot of methods, it's fun, but we're starting to create some intermediate object allocation that we might not want. Okay, so that's with output to a terminal. We will get back from there. We'll get back to there in a little bit. So another scenario is, for example, an HTTP server that we want to output some JSON. We want to be able to do a get to a certain URL and return a happy JSON of all the languages that should have installed in our machine. That's it. Only Crystal. And then, so let's review a couple of snippets that we can find here and there in different frameworks. For example, I don't expect to go through a whole detail of how to build an HTTP server, but from the standard library, basically we have the context that allow us to, per each request, this block will be executed, and we can send to the response IO something. And this is something that someone could write. We have an object, in this case it's a tuple, whatever, and there is already a method to JSON that give us the string representation of the JSON of that object. That is already available, is awesome. In Kemal, for example, or Chemal, I don't know how to pronounce it properly. If you go to the homepage, you can have more or less this. You create the object and you return to JSON for this route directly. This is one of the snippets that you can go and copy. Okay. And for example, in Lucky, something similar happened. We have some method that allow us to describe the route, and we say we want to return a JSON for the result of this this method. Again, we are returning a named tuple, and we are running in JSON. So it is expressive. It is clear what we are doing, that we are returning a JSON with certain specific fields. Everything is clear from the behavior of the program, from the functional behavior of the program. But the thing is, again, we are attacking the same evil as before. There are a lot of things that happen in between that we are not being aware of. In this case, there is a string created for the whole JSON representation, and then that string is sent directly to the response IO of the request. What is even more surprising to me is that in the previous code, it is almost impossible as they are written to avoid this intermediate object. There is nothing that we can do to avoid that if the code is already written like that. Because here, for example, here, this expression evaluates to a string. So that means that I will have a string with the whole JSON. In this case, it's just a couple of characters, but it could be longer. Here, we are using the same method as before, and this returns a string. So that string is, after being in memory, it will be sent to the response. In the Lucky, it's not clear that is happening because there is no explicit call to JSON. I have this JSON method that is provided by Lucky, and this object here, it is a named tuple. So I'm not sure from this code if there is an intermediate string being created before sending the response to the user. But if you dig into the Lucky code base, that is what happened. There is a whole string created with the response, and then that string is sent as a response. So in all these scenarios, we are creating an intermediate object with the resulting response before actually sending it. So that increased the memory footprint of our server and could affect our performance. And now, since we are an HTTP server, we care about that. On the console, well, whatever, we are single user, but on an HTTP server, we care about that. So, and there is, it is not a lot the thing that should change in order to reduce that memory footprint. For example, if we use the standard library example, we want to go from here, the one that's explicitly called to JSON that returns a string, to, for example, this one that give us, there is a JSON builder that is a helper to emit JSON, which is what is used in the toJSON method. But here we are saying, hey, object, encode yourself using this JSON builder. And this JSON builder was created already with the response IO as the target of its emissions, right? So coding this code like this, it will be output not to a string builder and then grabbing the whole string, but directly to the IO of the server. And another way to, this code is actually expanding to something like this. So maybe it's easier to imagine how this is working. In this call, there will be an open brace emit to the response IO. On this call, there will be the name of the field and the value will be encoded, adding the colons, and here there will be a comma appended because I know there is a field before this call in the runtime. That information is set, and the field name and the value crystal will be appending. So there will be, all the pieces will be submitted one by one, like atomically or granularly. Like there is never a whole representation of the object, of this JSON object in the server. It's already being sent to the socket of the client. So that is something really great because we are reducing a lot the memory footprint there. This means stressing less the GC. It's all good, but we need to write things really a bit more different than before, right? Because we, instead of writing this, we at least will need to write something like this, at least with the standard library as it is right now. Any question up to now?
Yeah, there's a comment in the chat that says, can we use like ob to JSON and pass context response?
No.
No?
No. No, but because the to JSON is restricted to the JSON builder. It's not that you get directly to the IO, but it could be added as an overload because it will still need to create this JSON build given an IO.
I see.
And maybe this is the overload. I'm just, if I will use that overload, I will need to expand that to explain it. So,
okay.
But yeah, it could be done. There is a nice thing of having the JSON builder, because if you have a JSON builder, it can be nested better with other objects. If you pass an IO, you kind of need the JSON builder your parent is using. So it makes sense to pass all the JSON builder, because you have the state of if you have emitted a field, if you are inside of an object. And so it can have an overload, but it only works for the top level. So it could work. Okay. Okay, the overload will exist. Great. I need to understand to underline the standard library. So this, let's keep going. For simple object, it doesn't seem a big deal, but for example, if we have an array of certain entity, if we call this method directly, we'll have a string representation of the whole array, of the whole collection. Hopefully you will be paging your results, but still, like, we are like having a huge string right now. So one idea could be to call to JSON with a JSON builder or with the IO, but that still leaves us with the need to have the array of the entities. Something that works for really good for JSON builder is, for example, you don't need the whole array to encode the array as a JSON. For example, in the next example, we will see how from a database connection, we can encode almost directly one at a time the entities using the JSON builder. So, and there is never an array of all the entities. Basically, going back to the HTTP server, here we are creating a JSON builder attached to a response IO again, and say, hey, I want to start an array. I still don't have any of the entities, but let's open an array. So that will be creating, that will be sending a square bracket to the context response. And then we start querying the database. This method will get executed for each entity returned by the database. So here, what we are using is method for CrystalDB that will grab the ID and the name field, create an instance of this named tuple, and that named tuple will get encoded using the JSON builder directly. So one entity at a time will be created from the rows of the database and will be sent to the response without never creating a whole array in memory on the server. So this reduces a lot the memory footprint. After each to JSON, there will be a comma appended because we know that we are emitting the array. That's pretty neat of the JSON builder. And finally, when the array is finished, a closing square bracket will be printed. So that's it. That's the JSON array. And we can see that even if we are in the middle of emitting certain objects, we can pass that JSON builder to other functions, and they will collaborate in the whole response, one piece at a time. So this is something that when I see that JSON is returning from an HTTP and that creates a string with a whole response, I suffer. So don't do that, please. There is an ability it is a possibility to do it directly to the response. But we can go even one step further and just stick to me. Again, I'm stretching it too much maybe, but I find this exercise really nice. Like, we are loading the whole entity. In this case, it was a named tuple with ID and name, and that's it. Using their convenience way for called DB mapping or DB serializable right now, that allowed us to create a whole entity from a database row. But we could not even need that, because, for example, if we want to go into dig even more, we can read one field at a time because we know in which order the fields are coming, and create those fields directly. So in this snippet that we are changing the body of how we process each row, we are not even allocating a whole object. We are grabbing one field at a time from the socket from the DB and forwarding to the HTTP. So I think you can get like, yeah, you're still allocating, yes, bro. But it's the minimum. You are allocating the string that goes from the DB, and you get the number. You're getting that chunks of minimum information, and you're not allocating anything more. Depending if you're using a named tuples, maybe the overhead is not that much because named tuples are allocated in the stack and blah blah blah. But if you are using classes, you will have a heap allocation. So there's a lot of the devil is in the details, but we're assuming the worst, and we want to avoid as many allocation as possible. But even worse, or even more, another scenario is like, what happens is if the DB has a huge binary or a huge text field, like many kilobytes or megabytes of information because it's a whole post, whatever, or an image. So that will come in two more slides. That is something that will impact a lot. If the entities are small, everything is okay. But if the entities are huge, the same code that I wrote before, it doesn't work anymore. I don't like that. Like, I know that code is specialized for each situation, but it's like we need a whole different solution based on we have a huge string field that I want to meet. That bugs me a little bit. I think Bill was asking for this, to a slice, reuse slice. Yeah, that's another idea. Yeah, definitely. We can reuse, memoize the storage. Yeah. So what we can even do even a bit more, or in some specific situation, here in this code, we are assuming some stuff that can be used. The thing is, JSON doesn't require us to put the fields in order, because it's not an information of the object in which order the fields are. So there could be a situation where we don't know in which order the information will be coming from. For example, in this query from the database, there is no guarantee whether ID or name will come first, right? So if we don't know that, maybe we need to use some code to say, okay, the first column is the ID, we need to store it here, the second is the name, or the other way, and that requires us to store that information in memory. But in certain situations, we just don't care, because the output format is does not rely on specific order. So in this case, we can code that. All this story about from database to JSON is covered in a blog post. That's the short URL if you want. It's written a couple of years ago, I think already. But it goes into the details, and it also uses ND-JSON instead of JSON. So instead of array, you get one JSON at a time, and it's good for streaming, for example. But well, so I want to go back to this node that I had, like what happened if there is a huge blob, because the database is a stream of information, and a blob in a field, it could be also a stream of information. So something that I would like to be able to do is I want to copy that stream that is coming inside the socket of the DB directly to the response output, or even more, to use it as a JSON, in a JSON parser, to build the object without allocating the JSON document in a string, because the JSON parser is already available for transforming an input IO as an object. So why do I need to, if I have those two pieces in the runtime, why I need to go to a whole document with all the information stored? So this is one of the idea, to have like some way of getting like a sub IO, an input IO from a database connection that will be valid as long as there is no other read to jump to the next field. That depends on the protocol of the database, and it goes really into a little nasty things of implementation of the protocol and how fields are coming. But this is something that I envision, like being able to, for a huge field on the database, get an IO that could be used there, right there, without allocating intermediate document. Someday, hashtag. So far, we focus a lot on intermediate object created, and the result is that to achieve that, we might need to express things different. That is the whole effect. Like maybe on terminal with the std-out, with the JSON, the situation is that like we are changing how things want to be run, although not changing what the program is doing, and we need to express things really different. And the thing is, are we early? Maybe it can be seen as early optimization, but what I want to focus is on which building blocks could be more fun to have, to code, and if possible, perform even better. I have covered all this, yeah. Yeah, I have covered performance come from a meeting. Yeah, so the performance is between if I computing the result and then sending the result, or computing directly in the stream, taking advantage probably of the order of the fields if it's possible. All those are choices that can be made, but that affect a lot the code. To motivate another example, let me bring another situation. For example, on ETLs, that is extract, transform, and load information. It's usually for like converting CSV to JSON, CSV to database, database to CSV, database to database. It's a small programs that we expect to be processed one row at a time or one field at a time, and we focus on the transformation of information, and we don't care how things are resolved. But the thing is that since we express how the information should be transformed, how the information is loaded and stored could be optimized without affecting the program. That is because the ETLs are usually written in a way that it's not a bunch of spaghetti code. You focus on the transformation and you plug the load and the store, and things can improve without changing the code. That's a nice example. I'm running out of time probably, but I want to go into the input streams, which is one of the, I want to mention one example, and then I will sum up with some hopefully not so weird ideas. So input streams, there is one input stream that is usually a headache, and is the HTTP form data. Because when you get requests from the HTTP, you have the query string that is usually short, not that long. Maybe you have a form post with only small text information. But when you have files, it's usually a headache. Usually the payload, when you receive a post with a multi-part form data and files, it looks like this. You will have like different parts of the request. Along the way, there will be some fields with the value, but there could be some fields that are a whole file, and there will be a lot of blob information. So the input stream for the server will contain this, and once you read, you can't go back. You just move forward because the information is gone unless you store it in memory, but we want to avoid that as much as possible. So if you go to the documentation of the API of form data, you will have more or less this example. This is an HTTP server. We have a name and a file variable, and we have this block that allow us to say how we want to parse the request body. And this block will get executed for each part of the request that we have seen before. It will be executed by this part and this part, and that's it. And then it will go away. So this will be like a loop for each field. And you don't know in each part which field is coming, because the order is no guarantee, right? So this code is basically finding which part is coming using the part name, and using the part's body, you are either getting the whole string, that will be the name, or you will do something with that IO to save it to a local file or do whatever and store something in this variable that is a file handler or a reference to that. So this will execute and process all the request body. Then you will validate that you have all the pieces together, because maybe you don't know, there is no guarantee that this will execute for all the parts. And then effectively you will call something. So clearly there is a room for a web framework to handle this situation, but at the end of the day, this is what happens, okay? I will assume yes. This is the situation. We collect information, we store or we keep a handle, we validate, and then we perform the operation that we want. And maybe, again, this, for example, if we want to store that information, that file somewhere, maybe we need to reread it again. We are storing temporarily in a temp folder and then read it again. And the thing is, in the situation, either if we want to store that blob, that file in a database column, not the suggested thing to do, but okay, or store that in a storage service and keep a reference, there is a way, there is a program that you can write that performs all those operations without storing the temporary file. So my question is, why is it not executed that way? How we can write something that is fun and can execute in that way? And even better, what happens if we have a collection of files and we want to composite the solutions of we deal really good with one file, how we go to a collection. Spoiler, I'm not going to answer that. But I want to review more or less all these different situations in a more generic way. And the thing is that there are pieces of input information, they are transformed, they are mapped. Sometimes there is no transformation, and then eventually we go to an output to go to the next stage to do something with that information. Maybe it's the first name and last name of the user and show it to the screen, or printing the hello world, or encode it to JSON. I am focusing more in the information. And since I think I'm thinking of mapping information from one source to another, but I feel that the code that I have shown is more about how data should be moved from one place to another instead of the transformation. So although resource allocation was mentioned a lot, the thing is, this is my main thing is that it teaches the difference between mapping information and moving code around, moving data around. Is two different codes, and it's not so fun to call the part, to change the code depending on why you want to run it somehow. So I always want to write code that is more similar to my mental model, and it's really subjective because it's my mental model. Maybe it's not shared with my coworkers, so it's a slippery slope there. Maybe first we need to agree how we want to express a problem that is comfortable to everybody. But this is something I want. Like, I want to feel comfortable being able to express my mental model, my ideas, and not have a lot of bureaucracy, like things need to be stored here or not, or temple. I want to be able to read what the program is supposed to do. So I have a couple of ideas. That's it. It's like follow at your own risk, definitely. But this is some ideas that I would like to have when coding. For example, I am really a fan of DSLs, of domain-specific languages. And for example, I could imagine like this kind of programs that allow me to express transformation from input to output somehow. Like, I have an output, I have fields, like this is valid crystal syntax, for example. So if here is all the information for the transformation available, can I then say somehow how I want to execute it? If I want to load the whole data in memory, and process it really fast. If I want to process that one at a row or using a strategy with less memory, whatever, like, can I have something that allows me to express the transformation this way? This is definitely a desire. But also when you are doing DSLs in Crystal, for example, there is a chance for you to, and it's a topic for a whole different talk, but it's the seed for me. It's like how you can write this to be type safety, so you get some guarantees that you are not messing around between age and a string, like how you assert those kind of information. What are the things that needs to be around this to have this kind of DSLs in a type safety way? And one maybe more known example is DSLs for routings. For example, I have done some examples when you express controller, hash, and action, and that can be just a string, or it can be checked at compile time that method exists for that compiler. Depending on the DSLs that you use, you can reach that level of guarantee. So that's important. But it was also a nice exercise to design this. And usually it could allow us more composability because you are focusing on a specific problem, and that allows you to focus better, I think. Another things that allows you to express different programs is the use of embedded languages. We have one already that is ICR. This is a templating language. It allows us to, basically it's a string interpolation, but more expressive. You have loops, you have conditionals. It's really much more expressive than string interpolations. And it's compiled, it's type safe, it's great. But somehow you don't use it for just generating the full name of the user. It's like using them is not trivial. It comes with a bit of cost for the program. But then, for example, there is another embedded language used in Rails that is called JBuilder. That is a language that allows you to describe mapping, for example. So my question is, can we have an embedded language that could allow us to emit the JSON that we have seen before, but let the decision if the field, let me come again, like have something like a DSLs that to define which is the JSON given the input information, and when we run it, allow at the runtime to decide, hey, I have this information already available, so I can emit this field, or maybe this one can't. Like, it's some decision that I don't want to handle when I am defining the schema of the JSON that I want to send. So definitely there are just a couple of ideas. And every of these ideas have the challenges of how to express better the program, how to, if there is a compiling error, how to report back something useful. If there is a runtime error, how to have a back traces. This is solved in ICR, for example, because you have the error propagation of locations there. So it was really good, but it's something that needs to be handled. It's not only just designing the language. You need to have all this feedback loop there. So as a summary of what we have seen is specific scenarios for input and output stream, either console or HTTP for input and output, the last one, how the standard library can be used right now, today, what code smells to avoid for, especially for allocating JSONs in memory, please, like, don't do that. The other, feel free. Some specific idea for the future of crystal-db, for example, how to handle I/O, which is a debt that it's been there for a long time. I have never even expressed what I imagine, so I wanted to take that time here. And some possibility to extend Crystal to handle the string interpolation, for example. Some weird, happier ideas for programming using DSLs or embedded languages, whatever. Like, it's not that you only need to code using raw crystal. And that's everything I have to say about it. Yeah, thanks. That's the information.
Thank you so much.
Did you update it?
No, I just wanted to do the last few slides on that.
Okay.
I will.
Have any questions, by the way? I thank you for Brian for doing this. This is definitely nerve-wracking to do any talk and to do one remote. I'm really glad that Brian stepped up to do it. I noticed that there was a JBuilder. There is a JBuilder library. I'm not sure if it's super actively. It looks like it's actively maintained. I'm not sure what the maturity of it is.
The JBuilder?
Yeah. Yeah.
I'm not sure. Haven't seen it.
Stop sharing when you get a chance. We're gonna put up a little info on the screen up here.
Yeah, sure. How?
I haven't seen another language that. Oh, we have some more questions.
I have a question for him because you mentioned, I think, what was it, that JRC or something? I just captured that having to do with syntax patterns, dynamic syntax patterns, the DSL for dynamic syntax patterns or something like that. Is that right?
Yeah, he's wondering about your dynamic DSL for syntax patterns.
It's just a wish.
Just
Wish. What was the question about?
It's not done there, and it's just a draft idea.
Okay. I was just curious about some possible examples of some possible patterns that could be done in that. I mean, because it was something like it's like a super meta version of, say, regex on steroids or something like that, basically. Yes.
It could be a lot of things. There is, like, in this particular thing, there is a lot of things to uncover. For example, what type are these variables of? For example, it could be something that allow us to execute this in a symbolic way to understand the dependencies. Or is this a macro that accepts the program and I build a dependency of the information between input and output? So I'm able to execute this block if I have these two pieces, or execute this block if I have this piece. That's about, like, dependency tracking, and maybe can be done directly from the expressions. That's something that I will imagine I will be really neat. It's more like cell programming than procedural programming. But also it's like how you get this type of information, how you know which fields are available based on the type of the input and output source. There's a lot of meta programming there, or reflection. Maybe the more similar things right now that I have seen is in Lucky, where you have query and you know that you are querying certain entities, and you can use the fields of the entity because they are build a version of the field that accepts a blocks, and it will allow you to compile this code. All those kind of things needs to come together to say, hey, I have this DSL, and it can be embedded directly in Crystal, and it will be really cool. But they're just ideas.
In this case, it's like, smells like a pattern matching, you know, when you have certain objects coming in, because they're like, the details are hidden away, and the pattern matching essentially, like, oh, if it's this, then that, right? Something like that.
Yeah, it could happen. Like, from this code, it could be executed like, hey, I want to generate this, so you evaluate that, and then you execute this block and you evaluate this. That will be like more a procedural way, or it will be more similar how the route matching is performed, because you have all the routes defining on an HTTP server, and you have like a case for each string execute certain code. But you can even, like, with the same code, you can do what I was trying to explain before, that say, hey, I understand that first name and last name are dependencies for name, and date of birth is dependency of age. You can gather that information from the syntax, from the code, without even executing it, for example. And then as soon as information start getting in any order, you will determine, hey, I got the first name. Okay, I can't do this because I need another piece of information. Hey, I got the date of birth. Okay, cool, I can execute this, whatever. And then when the last name comes, you finally execute this. So there is a lot of semantics or execution that could happen with this code. And I love that because it means that this is expressing an idea and not a sequence of statements. So for me, that is more expressive. It's much more my mental model because I am figuring what is the name, what is the age, and like just deal with that later, with what is the strategy to execute that. And that is definitely a personal itch that I have with code, and I usually doesn't solve it. It's just still there, stay there from project to project.
I'm really fascinated by how Crystal handles I/O and does a lot of the streaming. I knew there was some magic under the hood doing that because I went through and was doing some type annotations for the 2S stuff. But it's really cool, all the stuff that the core team has put into the, like, even just the basic puts and 2S's. Like it's already so much more performant than, and also just like it's so easy to read than other languages that I've seen. It's pretty cool.
Yeah, part of that, I will say, especially for the input streams, in other languages, when you have callbacks, if you are trying to read from a socket for HTTP request to get the response, you get a callback, and that means that the execution will happen later when the callback can be executed, right? And that means that the code is less linear because you exit the main function and then the callback will get executed somehow, and you need closure for the variables and all that. That, thanks to the scheduler and the runtime, which is more a talk for the fiber talk that people are asking. That is how the fibers are suspended if you are waiting for an input IO. Like your instruction pointer on that function is stopped and deallocated until the IO is fulfilled somehow, and then you get the response. So that is the core aspect that allows you to write more linear code and more easier to understand in a more classical, because you are waiting for that to finish and you don't need to use a callback to express that. That is one of the core things of the concurrency model that we have.
Makes sense.